All right, let's get into it. If you're revising for your GCSE in computer science, then you are in the perfect spot. We're diving deep into the OCR J277 spec, focusing specifically on a super important topic, network security threats.
But hey, before we start, just think about this for a second. How secure is your digital life, really? I mean, every single time you log into something or connect to Wi-Fi or even just open an email, you're basically stepping onto a digital battlefield. Understanding the threats, that's the first step to winning. And trust me, it's a huge part of your exam.
So here's our game plan. We'll kick off with the basics. What even is network security? Then we'll get into the nitty-gritty of the specific threats from your syllabus, things like malware, social engineering, brute force attacks, the whole shebang. And we'll wrap it all up with a really clear revision checklist to make sure you're ready for your exam.
Okay, first things first. What do we actually mean when we say network security? This is a key term you're going to need to know, and it's all about getting to grips with the different kinds of attacks a computer system or a network could be up against.
You know, at its heart, it's actually pretty simple. Just think of network security as the digital version of the lock on your front door. It's all the stuff we do to protect our precious data, our phones, our laptops, and whole systems from anyone who shouldn't be poking around.
Right. Let's talk about the attacks themselves. We're going to look at the first two together, and that's because they're both about trickery. Malware is designed to trick your software, and social engineering, well, that's designed to trick you. These attacks are all about exploiting weak spots, either in the code or, just in human nature.
First up, malware. The name kind of gives it away, doesn't it? It's short for malicious software. Basically, this is any bit of code or any file that's been built just to cause harm to a computer, a network, or a server. It's the classic digital bad guy.
And malware comes in a few nasty flavors. You've got viruses, which act just like the real thing, latching onto clean files to spread. Then you've got worms, which are a bit cleverer. They can travel across networks all by themselves, self-replicating as they go. And then there are Trojans, which, just like that famous wooden horse, pretend to be something useful to trick you into downloading them. But whatever shape they take, the goal is always the same: cause damage, steal your stuff, or try to get money out of you.
Okay, next up is social engineering. And your exam spec makes a brilliant point here. It calls people the weak point. See, this kind of attack doesn't need to break complicated code. It just needs to exploit our basic human trust. It's a con, a hustle, plain and simple.
The most common type of this is phishing, and I bet you've seen this. An email lands in your inbox, and it looks exactly like it's from your bank. It has a big, scary headline: "Urgent action required." So you panic, you click the link, you type in your details on what looks like a real website, and bam, game over. The attacker has your login details. The whole point is to make you panic so you act before you have a chance to think.
Okay, so we've looked at attacks that use trickery. Now let's switch gears and look at two attacks that rely on just pure, overwhelming power: brute force and denial of service, or DOS attacks.
A brute force attack is, well, it's exactly what it sounds like. It's not sneaky at all. It's just an automated program trying to log in again and again and again, just guessing every single possible password combination until it works. The analogy of a thief with a massive keyring is perfect. They just try every single key until eventually the lock opens.
Now, with a denial of service attack, the goal is totally different. The attacker isn't trying to steal your data, they're trying to stop you from getting to it. They just flood a website or a server with so much junk traffic that it gets completely overwhelmed and just crashes. So then real users, like you and me, can't get through. It's basically a digital traffic jam.
So listen up, because this is the key difference, and it's a classic exam question. A brute force attack wants to get in. A denial of service attack wants to keep you out. One is targeting a single account with endless password guesses. The other is targeting an entire server with a massive flood of traffic. Make sure you know the difference between these two.
Right, let's move on to our final two attack types from the syllabus. These ones are a little more on the technical side, and they're all about getting at the data itself, either when it's being sent or when it's just sitting in a database.
So, data interception and theft. You can just think of this as digital eavesdropping. It's like you're sending a letter in the mail and someone intercepts it, opens it up, reads it, maybe copies it down, and then sends it on its way. You might never even know it happened.
And this is exactly why you have to be so careful when you're using public Wi-Fi, at a coffee shop or in an airport. If that network isn't secure, your data is just flying through the air in plain text, and anyone else on that network with the right software can just listen in and grab your passwords or bank details right out of thin air. It's scary stuff.
And now for our last one, SQL injection. Okay, this sounds really complex, I know, but the basic idea is actually pretty straightforward. SQL is just the language that websites use to talk to their databases. An SQL injection attack is all about tricking a website's database into running a harmful command it was never supposed to.
All right, let's look at an example to make sense of this. This is a normal, healthy database query. The website is just asking the database, hey, can you select all the information from the users table for the person with user ID 105? The database finds that one user, sends the data back, everything's safe and secure.
But look what happens in an attack. The hacker adds a clever little bit of logic to the end. Or 1 equals 1. Now, we all know that 1 always equals 1, right? That statement is always true. So the database is now being asked to find user 105. Or find a case where 1 equals 1, which is true for every single user in the database. So it just hands over everything. It's a massive data breach, all caused by that one tiny malicious bit of code.
Whew. Okay, we have covered all 6 of the major threats from the specification. So now, let's pull all of that information together into one simple, really powerful revision checklist for your computer systems paper.
Here it is, all the key facts in one place. You need to get this memorized. For each of these 6 attacks, you have to know what it is, the basic way it works, and what its ultimate goal is. Seriously, if you can explain those 3 things for all 6 of these threats, you're going to be in a fantastic position for the exam.
And that really is the big takeaway here. This isn't just about memorizing some facts to pass a test. In the real world of computer science, you absolutely cannot defend a system if you don't understand how an attacker thinks and what tools they're using. This knowledge, this is your shield.
So I'll leave you with one final thought. We've just gone through the attacker's playbook. The next part of your course is all about prevention. So now that you can spot these threats, how are you going to build the digital fortresses of the future to stop them? Something to think about. Good luck with the revision.